Well, in our previous video, we looked at how we use Demoivre'S theorem to prove trigonometric identities. But in this video, we are going to cover how we can find the roots of complex numbers using Demoivre'S theorem. This is somehow yeah, but we shall get it very well, but we just need to pay maximum attention. And there are other methods. There is another method that we can use to find roots, but in case they say using Demoivre'S theorem or Demoivre'S theorem, so you need to be knowing this approach also. So it's very easy, realistically, provided we know how to get modulus, provided we know how to get the argument. It is very, very, very easy. Very, very, very easy for us. So now we are going to suppose, I'm supposing, you know, Z of ours has always been in a polar form, R, or theta plus I sine theta. That is our Z. It means that Z power n is equal to R power n cos any theta plus I sine any theta. All right? Implying that if we have Z power 1 over n, it's the same as R power 1 over n cos 1 over n theta plus I sine 1 over n theta. So the general expression for finding roots of a complex number or of complex numbers is given by, let me call it general expression for finding roots of complex numbers is given by Z is equals to R into cos theta plus 2 pi k then plus I sine theta plus 2 pi k, right? Where k is given as 0, 1, 2, etc. And theta is normally given in radians. You can always express our theta in radians. Now, for nth root of a complex number, it would mean that Z power n would be equal to R power n cos n theta plus 2 pi k, right? Then plus I sine n theta plus 2 pi k. Right? Meaning that for 1 over nth root, it would mean that Z power 1 over n would be equaling to R power 1 over n cos theta plus 2 pi k over n plus I sine theta plus 2 pi k over n. We need to quote this formula for all the processes we are going for. That is how we get the 1 over nth root of a complex number. Okay, So we are going to have some examples. Right. We are going to have some examples. And the examples are: use Demoivre'S theorem, use Demoivre'S theorem, find the square root of Roman 1, 3 plus 4i, Roman 2, minus 3 minus 4i, Roman 3, 5 minus 12i. I will do part 1 and 2, then expectedly you do part 3, then other examples will come on. For this part, we are having for this part, we are having this, but from our formula, we really need to get the magnitude of z, which will be the square root of 3 squared plus 4 squared. This is 5, and this is the same as our r. So our r is 5, okay? Our r is 5, and the argument of z, which is equals to theta, is the tan inverse of y over x, which is 4 out of 3. And this is equal to 53.13. If you put this in radians, okay, you can even draw to show where it would really lie. So here we have the imaginary, and there we have the real. So we have 4, 3. So real is 3, imaginary is 4. So we have it here. It makes it with a positive x-axis. So this is our 4, and this is our 5. So you can see that it lies in the first quadrant. It lies in the first quadrant, and therefore theta is equals to 53.13, which is equal to, when you put it in radians, I said you say 53.13 pi out of 180. And this will give you 0.295 pi. Okay, now it means that our z would be equal to r. You check on the other forms, it would be r, which is 5 into cos theta, which is 0.295 pi plus 2 pi k, plus I sine theta 0.295 pi plus 2 pi k. Meaning that if we need the square root, z power a half will be equaling to 5 power a half into cos theta 0.295 pi plus 2 pi k over 2, any 2. Then plus I sine 0.295 pi plus 2 pi k over n, which is 2. All right, now having that, since we are looking for the square root, we shall, that value of k, we shall be substituting. So for k is equal to 1, we begin with the 0. For k is 0, we shall get z1. So z1 will be equaling to 5 power a half into cos k is 0, so the whole of this is 0, so we shall have cos 0.295 pi over 2 plus I sine 0.295 pi out of 2. So this is going to be I'm putting on my calculator. If you put on your calculator also, this is going to be equal to well, okay, so it's going to be equal to, this will reduce to 2 plus I. 2 plus I, all of it. Cos this plus I sine this times this, to reduce to 2 plus I. Then for k is 1, when k is equal to 1, it means that you have our z2. So it will be 5 power half into cos. Now it means that where k is, we shall be having 1. So we shall have 2 pi plus this pi. So it will come to 0.295 pi, of course, plus 2 pi, because k is 1. So we shall add 2 pi out of 2 plus I sine, let me put it here, plus I sine. Remember, the whole of this is inside of 5 power half. So I sine 0.295 pi plus 2 pi out of 2. So when you simplify that, you're going to get -2 minus I, implying that the square root of 3 plus 4i is equal to plus or minus 2 plus I. Mean that you can have positive of this, then it's negative. So that is how we get the square root. We are going to do very many examples here so that we trigger your understanding. So let's do number 2, and you see. For that part 2, where you had 3, it was negative 3 minus 4i. Okay. So the magnitude of z, which is equals to r, will be equaling to the square root of negative 3 squared plus negative 4 squared. So it's going to be still 5. And theta will be equaling to tan inverse of negative 4 out of negative 3. That is the argument, which is 53.130. But out of the sketch, you can really see in which quadrant it lies. We have negative 3 and we have negative 4. So when you plot them, you find yourself here. So this is the imaginary and this is the real part. So we have this, meaning if this is 53.13, what would be the angle from the positive x-axis? The angle from the positive x-axis, theta, would be in the third quadrant, which will be negative 127. We count from the positive x-axis. When you convert this one to radians, it will be negative 127 pi out of 180. That gives negative 0.7 pi. Now, this one would mean that z power a half will be equaling to 5r, that is r, power a half into cos theta, which will be cos negative 0.7 pi plus 2 pi k out of 2. 2 is always the value of n that you have, then plus I sine negative 0.7 pi plus 2 pi k out of 2. So for k is equals to 0, we shall get z1 as 5 power half into 5 power half into, now the whole of this is 0, so we have cos negative 0.7 pi over 2 plus I sine negative 0.7 pi over 2. Compute this, multiply by 5 power half. You're going to get 1 in this part minus 2 pi minus 2i, sorry. That is the first value. Then, since they need the square root, means n is 2. So for k is equal to 1, we shall get our z2. It will be 5 power half into cos negative 0.7 pi plus 2 pi over 2 plus I sine negative 0.7 pi plus 2 pi over 2. So this is, of course, you have to first add this and this. So it will come to negative 1 plus 2i, implying that our square root of negative 3 minus 4i is equal to plus or minus 1 minus 2i, meaning that it can be positive this or negative of that. As simple as that. So try part 3, but I'm still continuing with many more examples. I'm still continuing with many more examples. Evaluate negative 16 power quarter. Or someone can say, find the fourth root of negative 16. So that question can be examined in those 2 ways, but still they can be very easy. They can be very, very, very easy. Now looking at this, fourth root of 16, what do? We shall let z to be equaling to minus 16, of course, to the power quarter. Okay, and this is the same as one can use different approaches. Okay, so I'm going to give you another approach. So this is the same as 16 power quarter times negative 1 power quarter. They are same. They are the same. So now, after having expressed it like this, but the fourth root of 16 is 2. So this is 2 into negative 1 to the power a quarter. Now, having this is the same as 2 cos 180 plus I sine 180. How does it come about? How does it come about? Someone may wonder how I've gotten here. It means that since I let Z, I'm just trying to show you how I've reached here. Since I let Z to be 16 power quarter, then it would mean that this is the same as negative 16 plus 0i. We don't have the imaginary part, but power a quarter. So look for, if I let maybe my P, if I let P to be negative 16 plus 0i, can get magnitude of P. Magnitude of P is the square root of negative 16 squared, which will keep 16. Then argument of P will be equaling to tan inverse of y component, that is 0 over negative 16. So this is giving 180 degrees, which is pi. All right, but when we are writing, we just say that Z is equals to P power a quarter, because I relate this one to be my P. So it is P power a quarter, which is equals to 16 power a quarter, that is R power a quarter, into cos 180 plus I sine 180. But 16 power a quarter is 2, then cos 180, all right, plus I sine 180. So that is where I am now. But remember, I need the fourth root. So I need to go to as far as when, if I have this, so it will be, of course, everything will be power a quarter. Everything will be power a quarter. So even here, power quarter. So I'm going to have a 2. This negative 1 gives this, but then power a quarter. So this is the same as 2. This is the same as 2 into cos 180 is pi. So we'll say pi plus 2 pi k. Now the value of n will be 4. All right, plus I sine pi plus 2 pi k over 4. Now we start substituting. For k is equal to 0. For k is equal to 0, I'll get my z1 as 2 cos, this is 0, so it will be cos 45 degrees plus I sine 45 degrees. Why? Pi over 4 is 1/8 over 4, which is 45. Cos 45, then I sine 45. When you compute this is going to give you 2. This is root 2 over 2 times 2. So root 2 over 2. This will be 2 into root 2 over 2 plus I root 2 over 2. These ones will cancel. So you have root 2 plus I root 2 as your Z1. Then for k is equals to 1, you'll get Z2. Z2 will be 2 into, where, let's take pi as 180. Now k is 1. Then we divide by 4. So it will be cos 135 plus I sine 145 degrees. So this is going to give you negative root 2 plus I root 2. Okay. It is still 135 here. Yeah. So you get this also. Then for k is 2, we shall get Z3. And Z3 will be equaling to 2 cos. Wherever is pi, put 180 and then divide by 4. So, and wherever there is a k, put a 2. So this will be 4 pi plus pi. That is 5 pi over 4. Or you can leave everything in pi, still it is okay. Okay, so cos 225, even if you leave in pi, no problem, then plus I sine 225 degrees. So this is going to give you negative root 2 minus I root 2. Then finally, for k is 3, that is when we get Z4. For k is equals to 3, that is when you get your Z4, and it will be 2 into cos, whatever there is k, now you are going to put 3. So this is 6 pi plus pi, that is 7 pi over 4 That is 180 times 7/4, which will give 315. Otherwise, I've said you can leave it in pi form, then plus I sine 315 degrees. So it is going to give you √2 minus I √2. So that is my Z4. And that is where I am stopping. Therefore, after getting Z4, we shall conclude and say, therefore, the fourth root of -16 is going to be equal to plus or minus √2 on whatever case we have either positive √2 or negative √2. So that's why I'm saying plus or minus √2, then plus or minus I √2. Why am I putting another plus or minus? Because we either have minus I or positive I. So that is what we have as our fourth root. Or you can write all of them. You can write all of them. You can write this, comma, that, comma. All of them, you can write this, and that. All of them. So let every viewer, I'm continuing though, but let every viewer find the cube root. Find the cube root of root, of 27i. That is for everyone watching this lesson. Okay, I'm going to do more two questions. And then I call it a time with the Demoivre'S theorem. So find the roots of z power 4 plus 4 is equal to 0 using Demoivre'S theorem. So for this one here, you need to be very smart. You can find it in section A, 5 marks, or section B, connected to another. So here, what you have to do, z power 4. Z power 4 is equals to -4, implying that z power 4 is equal to -4 plus 0i, which can be taken as z power 4 to be equaling to negative, or I can call it 4 into -1. Sorry for this step. I can say z power 4 is equal to a 4 -1 plus 0i. So having this, I can get my argument. My argument of z would be equaling to tan inverse of 0/4, which is 180, similarly pi, right? Then my modulus of z is going to be equal to the square root of -4 squared plus 0, which is the same as 4. Implying that z power 4 is equal to 4 This one in polar form, it is this one in polar form, this complex number in polar form is cos 180. Okay. It is cos 180 plus I sine 180. Right? So relating to what we have always done, so it means that our z powerful is equal to 4 into cos, this is 180, which is pi, plus 2 pi k okay, plus 2 pi k, then plus I sine pi plus 2 pi k. Implying that z itself alone will be equaling to 4 power a quarter, fourth root. So the moment you take the fourth root, we shall be dividing by 4. So pi plus 2 pi k over 4 plus I sine pi plus 2 pi k over 4. So now I bring in the values of k. So when k is 0, okay, when k is 0, we shall have our z1 as 4 power quarter into cos pi over 4, because k is 0, so we don't have this part. So cos pi over 4 plus I sine pi over 4. So this is the same as, when you summarize this up, the fourth root of 4. The fourth root of 4 is root 2. So we shall have it as root 2 out of, rather into, cos pi over 4 is 1 over root 2. When you say pi over 4, look at 45, then plus I sine that, which is 1 over root 2 also. So this one will reduce to 1 plus I, whereby this one and this one will make a 1, this one and this one will make 1, but we have I that same. So for k is equals to 1, we shall get z2. So z2 will be equaling to 4 power quarter into, otherwise, some students who don't know how to express these ones in third form, they maintain decimal points, which is okay. Cos pi over 4. But when k is 1, whatever that is k, we shall be putting 1. So now this one becomes 2 pi plus pi over 4. It becomes 3 pi over 4 plus I sine 3 pi over 4. So this is root 2 cos 3 pi over 4 is negative 1 over root 2. Third form. Members, let's learn how to get these angles in third form. Or you maintain pi. Put your calculator in radians and take cos 3 pi over 4. Then plus I 1 over root 2. So this is going to reduce, you'll get you negative 1 plus I. When k is 2, we get Z3. So Z3 is 4 power quarter into cos. Now, this one we have 4 pi plus pi, that is 5 pi. So we have 5 pi over 4 plus I sine 5 pi over 4. So this is going to be root 2 into, this is negative 1 over root 2 minus 1 over root 2, but with the I. So this is going to be negative. This is going to be negative 1 minus I. When k is 3, we shall get our last value, Z4, because we are looking for the fourth root almost. So Z4 is 4th root of 4, which is root 2, into, now when k is 3, it means that this would be 6 pi plus pi, which would be 7 pi. So here we shall have cos 7 pi over 4 plus I sine 7 pi over 4. This will be root 2 into 1 over root 2 minus I 1 over root 2. So it will be 1 minus I. Applying that, therefore, the roots of z power 4 plus 4 are, you can list all of them, or you can say this comma, this comma, this comma, and this comma, or can summarize them as, because here you have 1 plus I, and here you have 1 minus I. You have negative 1 plus I, you have negative 1 minus I. So they can be 1 plus or minus I, because here you have 1 plus I, and here you have negative. Or another one is, here you have negative 1, negative 1. So it can be negative 1, then plus or minus I. So if you cannot get these angles, rather these values in root form, then you record your decimal places and be accurate. Still, you'll be fine when your calculator is in radians. But this one here requires you to practice to know what is 3 pi over 4, which angle is that, and what is it when I take the sine or the cosine of that angle, which takes you back to trigonometry to see how the trigonometric ratios match with the sides. Okay, so let me do my final question. And then see. Yeah, in case I see any other questions to add on, I'll be adding on. But for this will be somehow enough. Evaluate 1 plus root 3 2/3. Okay. That is what we are having. Evaluate that. So let's see how we do evaluate this. So solution 1 plus root 3 or 2 out of 3. Allow me to say that this is the same as 1 plus, actually was root 3i. Yeah, we have root 3i. So the question is 1 plus root 3i. So root 3i, right? So I can say squared, then power a third. So that I bring in the element of root. Because when it is 2/3, it becomes somehow tricky for us. Okay. So this is the same as 1 plus root 3i times 1 plus root 3, right? Then a third. This is what brings in power 2/3, because when you add the power 1, it becomes 2 squared. This is squared, then power third, implying that when you simplify this, it's going to be -2, right, plus 2 root 3i, then to the power a third. How does it come about? Members, I did all this so that I have that a third, the root, okay? But when it is 2/3, it is hard for you to express. So having brought 2 inside, it's a square. That's why I squared these 2. So I have 1 times 1, which is 1. Then 1 times root 3, that is root 3. 1 times this, root 3i, and then root 3i times root 3. We shall have 3. Okay. It comes to 3i, right? Okay. So 1 plus root 3i times 1 plus root 3i. Oh, there is another I here. So the expansion, 1 times 1, you get 1. This one is coming from 1 times 1, which is 1, plus root 3i plus another root 3i. Then because of this negative, it will be -3. Because I times I is -1, but root 3 times root 3 is 3. So -3. 1 minus 3, that is -2. Root 3i plus root 3i, that is 2 root 3i. So having obtained this, it means that if I let my z to be equal to -2 plus 2 root 3i, okay? So I can get my magnitude of z, which is going to be equal to the square root of -2 squared plus 2 root 3 everything squared. So this is the 4, then 4, 12, plus 4, 16. So the whole result will bring it to a 4. Okay, so this is 4. It is 4 plus 2 squared is 4 times 3, 12, and a root, which gives a 4. So after having gotten this, we can go ahead to look for the argument of z. Argument of z is the tan inverse of 2 root 3, that is the imaginary part of -2. So this is going to give you, of course, it is the tan inverse of -√3, because the 2 with the 2 will cancel, which will give you -16. But you need to sketch so that you know in which quadrant are we lying. In which quadrant are we lying? So if we do sketch that, we have our real and we have our imaginary Our real is -2, while our imaginary is 2√3. So we are here. In other words, we are in the second quadrant, okay? Since we are in the second quadrant, we are looking for this angle from the positive x-axis. So if we get our theta, so as 60, we are looking for this angle here. So it will be 180 minus 60, which will be 120. So our angle will be 120. So it means that this is equivalent to 120 degrees, but 120 degrees is the same as 2 pi over 3. Where do I get 2 pi over 3? Get 120 pi, you divide by 180, you get 2/3 pi. So after having gotten this, it means that our z now, if I'm to write it in polar form, it's going to be 4, then cos theta, which is 2 pi over 3, plus 2 pi k, then plus I sine 2 pi over 3 plus 2 pi k. So it means that z power third, because we are looking at the cube root now, we reduced it up to the cube root. So z over that will be equaling to, here you can get the LCM, and then you move a 3 down. So it is going to be 4/3, 4 power third, cos it will be 2 pi plus 6 pi k. Why 6 pi k? LCM is 3, so it will be over 9. Why? Because after getting this LCM here, it becomes the whole thing before bringing a 3 inside, it is 2 pi plus 6 pi k out of 3. But then you have to bring the power down. So it will find this 3, it makes it 9. Okay, plus I sine 2 pi plus 6 pi k out of 9. Then now we start when k is 0. When k is 0, we shall get z1, which will be 4 power third into cos 2 pi over 9 plus I sine 2 pi over 9. So this one will get you now, like this one. Let me get my answers in decimals. So I get 4 power third. I'll be multiplying cos theta and then later in sine theta. So it is going to be 1.2160 plus I, or plus 1.2160 I. When k is 1, we get z2. So it will be 4 power third into cos. Now, wherever k is, put 1. So it will be 8 pi over 9. So 8 pi over 9 plus I sine 8 pi over 9. So it will give you negative. When you take the cosine of this and then you multiply 4 power third, to give you negative 1.4917 plus 0.5429I. Then you go to when k is 2. When k is 2, that is when we get the third root or the cube root. Be 4/3, 4 power third. Of course, now when k is 2, substitute 2. It will be 12 plus 2. That is 14 pi out of 9. 14 pi out of 9 plus I sine 14 pi out of 9. So this is going to be equal to, the real part will be 0.2756, 0.2756. This will be a negative 1.5633i. So we've gotten Z3. Therefore, 1 plus root 3i to the power 2 out of 3 is equal to, you write everything, 1.2160 plus 1.2160i, comma, you write this, comma, you write that, comma. That is how the answer is supposed to be. Interestingly, I'm going to give you some numbers to do. Through your comments on my YouTube channel, I can get where your problems are so that I pull you from there. Okay. Exercise. Solve z power 4 plus 1 is equals to 0. 2. Solve z cubed plus 27 is equals to 0. Of course, you strictly use Demoivre'S theorem for your practice so that you can get it very well. Okay. Otherwise, the other methods that can get you the answer, but since we are looking at this, let's strictly use Demoivre'S theorem. Then there are very many numbers that can be done. Okay. I'll first do these ones and we see. Maybe, let me see, for purposes of further revision. For purposes of further revision, yeah. But I want you guys to first do those. Then just in case you need more work, I can get your feedback. Okay, I can get your feedback. Next lesson, we shall be looking at the locus of a complex number. Wish you well. Thank you for listening.